Well, I'm going to say first and foremost, thank you very much to the organizer, and thank you for coming. I'm not a modeler. I'm an archaeologist who has worked with and who keeps working with modelers. So in many respects, having to give this talk, in a way, it's not good for my imposter syndrome, because I'm not sure I am a modeler and I will never be a modeler. But on the other side, it was a good also reflection upon a personal journey from a fairly average training in a fairly average university to what I think is trying to be slightly better as an archaeologist. So it's a journey in trying to be a bit more formal. It's also a journey, though therefore there have been lots of people, and you'll see a fair amount of pictures of the various people with whom I have been working in developing some of those ideas. So because I want to be a bit more formal, let's try to start with definitions. So my talk is called The Fallacy of Holism. So what is a fallacy? And here I've just taken Google. It's a mistake belief, especially one based on unsound argument. The second one is more interesting, and let's start with that one, holism. So it's the theory that parts of a wall are in intimate interconnection such that they cannot exist independently of the wall or cannot be understood without reference to the wall. I think that as an archaeologist, and many people in humanities and social science, explicitly or not, we've all been trained to consider that humans are holistic. It's one of the key behavior. We're kind of bizarre. We link stuff in not necessarily straightforward ways, so that there will always be, for instance, an ethnographic example where the economy has been linked to ritual or whatever. So it is holistic. I'm not questioning that. The reason why I think it's a fallacy, it's in the way it is generally used as a theoretical or as a methodological argument in the way the discipline, especially in archaeology. And what I've discovered in this lovely gentleman is Field Marshal Jan Smuts, who developed, and one of the very first person to have actually developed the concept of holism. And what I've also discovered, thank you to Wikipedia, is the fact that this man was also a very strong supporter of apartheid. So on the one hand, you have someone who, in his intellectual life, was stressing the whole, but in his political life was all about segregation. And I find that quite neat. So why do I not think that holism works? Archaeology actually has a long history of holism. There is the one I call the hard holism, and I'm very sorry about the fact that the graph is so blurry. I tried to reproduce it, but there's an awful lot of arrows, and I just got lost in trying to reproduce it. So for the non-archaeologists, this is David Clark, one of the founding father of processual, the user of system theory in archaeology. He strongly believed that all of these various elements of the world were strongly linked with system, feedback, loops, and so on. But it came at a hard methodological price. For him, it was all about how can we actually also describe the data in a formal way to try to identify all of those loops and feedback and get to the system functioning. That's why I call it hard, because it came at a methodological price. Whilst there is another thing, which I will call the soft holism, and here is the picture of Jan Hodder. What would be the word I would use for Jan Hodder? Is a key figure, kind of a guru figure in the development of a more postmodern or I can't remember how many post-processual archaeology there are now in the discipline. This is one of his latest production. It's called the Tanglegram. So it's linking clay, and clay is linked to everything, which is kind of correct from a very limited point of view, but does not help us to actually do something or say something. And that's what I call the soft holism. And unfortunately, the soft holism is very, very present in quite a lot of the discipline. And when you start to do any sort of modeling, let alone agent-based modeling, it will kind of be used as a trump card, but you're not holistic enough. And that's what I sort of disagree, because let's face it, this is what we're supposed to do holism with. And that's just for Maya. That's the site where I'm excavating and where I hope to get Maya. as Edmund has just said, archaeological data are just not that good. So in a way, yes, holism should be the goal, but there should be also a series of self-imposed limits upon what we can do, how we can do it, under which condition we can do it. So this is one way of looking at what the archaeology is. And the title is actually an echo of a definition of archaeological record by David Clark. And let me quote in full. It's a sparse suspension of information particles of varying size, not even randomly distributed in archaeological space and time. Therefore, archaeology is the discipline with the theory and practice for the recovery of unobservable hominid behavior patterns from indirect traces in bad samples. When you've read that one, either you change discipline, or you do soft holism, and hee-haw, anyway, it's bad, and I can do whatever, or you just take on the challenge. So what do we have? We start with the past. We have past population, past activities. These guys leave us, amongst other things, a variety of locations. We have settlements, we have cemeteries, fields, and so on. Some of it will enter what we call the archaeological record. The way it will enter the archaeological record is in many ways. It can be through remote sensing, it can be through survey, it can be through excavation. Of the stuff that will be excavated, some will be dated, some will be studied for archaeobotany, some will be studied for zooarchaeology, and so on and so on. So what do you get? Well, you get this gradual, massive loss of information. This being said, the narrower the arrow, the more data you have, because it's compensated by the fact that you get quite a lot of data, even if it's only concerned a very, 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 very small portion. So that's the positive part. The negative part is that if you try to go the other way around, you just don't have a clue. So if you have robust data collection, for instance, in a region, you might be able to control the relationship between the number of sites for which you have plant and animal remains and how it relates to the number of dated sites. That's kind of okay. How the number of dated sites relate to the number of known sites, that's getting a little bit more complicated. How the number of related sites actually correspond to the number of sites excavated or waiting to be excavated, and how does that relate to what was in the past? Don't know. As I said, it's not a problem. It's just what we have to deal with. Just get a grip, or just change discipline. I kind of got a grip, and all I try to do in various ways, and I think that models or ABM in a way is a way just to get a grip with that. The problem with the underlying soft holism, to call it like that, is that given all those uncontrolled bias, the attitude towards models, formal models in archaeology, is often something along those lines. So you're trying to predict the behavior of archaeology? Well, just model it is a simple thing, and then add some song stuff. And that's when you present a model in archaeology, that is generally the first reaction. Oh, it's too simple. And there's that sort of, it has to be more complicated, so get a grip. Sometimes you get people who are slightly more sophisticated and who also say, well, you can always try a plot, and there will always be a way to fit a story to the plot. It's very rare to actually have people who will use the kind of holistic approach and at the same time who have enough quantitative flexibility to actually come with both. And I think that's something that irritates the hell out of me. In a way, I know that I will never be able to be holistic. Just get a grip. I've got a grip to that. That does not imply that I cannot try to define certain types of objects and that I will not try to understand them in various ways. And I will try to do that in a formal, explicit way. That's one of the advantages of the models. They have to be formal. You can be formal in a literary way, in a narrative way. It's just a little bit more complex in many ways and more difficult to implement. So that's one of the reasons why I think that ABM can be just good. Not because they can help us to say it all, but because they force us to admit that we cannot say it all. Therefore, we have to think carefully about what is it that we think we can do and under which conditions. That's probably one of the reasons you can consider that ABM is still niche. That's taken from a review paper on ABM in archaeology, and I've put the original quote because they're kind of positive about it. They say, a review of the use of ABMs in archaeology shows a rapid growth in the number of publications since 2000. That's the original quote. So yeah, keep on going, guys. From 4 to 9. That's less than the number of papers in the issue of an average archaeological journal. So I think there is a problem. It's a niche. It will probably remain a niche because the discipline is actually organized, fieldwork and other stuff, but it has to be a growing niche because there is quite a lot that can be done. So let's just be positive. So when I was introduced by Frederick, he mentioned this hideous title called Integrating Qualitative and Social Science Factors in Archaeological Modeling, which is this edited volume which is now in press with my colleague Mehdi Sakali. Why did we put that title? I have no idea, especially that Troubles and Processes is actually the title of the conclusion. That is so much better at the title. At least we will have sold 3 copies of the book rather than just 1. Never mind. So in a way, what I want to give you now in the next 3 or 4 slides is that's the outcome of an awful lot of reflection with Mehdi. These are not simply my ideas. I mean, not necessarily be entirely only Mehdi's ideas. It's a dialogue, but it's something that I want to acknowledge. This is the product of a reflection between a modeler and a down-the-ground archaeology, I like to have my boots dirty kind of guy. That's me. So one of the things that we contrasted, there is this issue of holism, or this issue of complexity. And quite a lot of time, people who criticize models say, oh, you're not very complex. But actually, I think that on both ends of this, we start with the acknowledgement that it's complex. We just tackle it in very different ways. So for the modeling point of view, and here I actually quote directly one of the 2 papers we have in this volume, we consider this as a sort of impressionism. It's an initially gross, blurred but global image, which will improve as we have a more detailed process of local dynamics that will affect the local system. So you have a model, and then you can put in, you can calibrate, you can validate, and you will have something that is blurry, but that hopefully will get a little bit better. That's the one way of tackling that core problem of the complexity. Whilst a more field archaeology is what we call the Pointillism approach, which is that you have a series of field dots, each will provide limited but significant information, eventually leading to a meaningful interpretation through accumulation of sufficient number of dots. And there is indeed that strong ethos that more field work will help us. And it's actually somewhere in the middle. But defining that middle, that's something which is a little bit more complicated. Another thing that we discuss is the difference between what we call mimicking and reproducing. So we will never be able to reproduce the past. And what I've actually put for reproducing, thank you, Wikipedia, once more, that is the first xerography ever made. It's kind of a sweet thing. We will never be able to reproduce the past. We can dig a lot. You have landscape which have been dug extensively where everything has been done. I've done that in commercial archaeology. There's one site I know full well that my 4 hectares, everything is there. But I will never be able to reproduce. You can try to model, you will never reproduce. But that is not the goal. The goal is something about mimicking. And here I have put something which I find really beautiful and vicious. This is, if you count the number of legs, this is not an ant. It's actually a spider that mimics an ant. I'm not saying that ABM should be vicious. I'm just saying that this is what it is. We are mimicking. That mimicking is something that we have to be explicit about. It's something that comes at a price. Now, there are ways not simply to mimic and to have 8 legs instead of 6. So what are those things? So some of the things that already have been mentioned is, for instance, what are the parameters? Well, one of the things which I personally find extremely important and extremely beautiful with agent-based models is that they are, because of their making, they are flexible and they allow you to actually put an awful lot of people around the table. That is one thing. You might be an archaeologist, but you may have someone who's more of an ecologist, some more of a physicist, and so on and so on and so on. So that is one thing that is already good. You put various people around the table. But that comes with a series of very important decisions. The first decision is, and it's something I will go back to in my conclusion, which is humility. Everybody is on the same floor. Everybody's at the same level. Just get a grip. The other thing, and that's a concept that actually is key to Mehdi's work, it is the concept of sacrifice. For the model to work, for that discussion to work, you may have to be ready to sacrifice some of the complexity of your own data. Just because you can try to say, oh, I mean, actually, in archaeology, it's slightly different. We should have the... No, no, no. You have to make that decision that you will, in a way, dumb it down so that you can keep that level of dialogue going on. And that is very difficult. Because there is that kind of mimicking limit, that leads us to another thing, which is what kind of model. And that's something that Edmund has already gone into, and where I think that we have a very different standpoint, because I'm an archaeologist. It's the keep it simple, stupid versus the keep it descriptive. Okay, let's just say it like that. I have children. I love my children. I love to see my kids, and I love to see kids in a playground, but I find it extremely disturbing. There's just too much going on. It's very chaotic. And I have issues with very descriptive system, especially from an archaeological point of view. It's actually not a statement regarding the kids' approach per se, just because we cannot calibrate, we cannot validate, we overfit. There's just too many parameters we sort of don't know. So I'm naturally inclined, because I am an archaeologist at heart, to go towards the KISS end thing. This being said, and here is a model, it's the outcome of a model published by James Conley a few years ago. And what it shows is that you have a population, and they have a package of cereals. You'll understand in a minute when I'm going to my case study why this is a model which is important. And the idea is that the smaller the population, when people die, the likelier that there will be a reduction in the amount they have. It's just sort of, yeah, that's kind of self-evident. And indeed, a lot of KISS models in archaeology have been very, very navel-gazing. They tell you something about the theory which is underpinning them, but I am not sure how much they've actually helped us to do something. And there is that in-between, which is goddamn hard to define. But I am naturally inclined to go towards simplicity. This being said, simplicity comes at a cost. Don't know if you will get the joke unless you are really into physics model. Physicists love to have simple models. Frictionless vacuum environment where there is just no parameters. That's what it happened if you translate that in the real world. Everybody dies. It's just not possible. So I know that thought experiments, models as thought experiments, comes at a price, but I am ready to take that price because I think there is an in-between. And I would like you to show you what I have in mind, that in-between, through a particular case study. So what I'm going to discuss is the spread of farming. So domesticated animals, as well as a series of domesticated plants. The process of domestication per se happens in the Near East. And then you have a diffusion across Europe. And we have a lot of C14 data. You can do this kind of geostatistical treatment to show that it's a very complex process. And for instance, you have one stream of diffusion that will follow the coast, another one inland, and then the diffusion will stop and then resume in these two islands, and especially that one, which is a bit of a problem child these days. That we know. What we also know, and that's the problem as an archaeologist, is that it comes with an awful lot of variation. When you look at the archaeology, when you look at the stuff, it might be always the same cereals and the same plant that eventually come from the Near East. It's a process that unfolds over a long period of time, which has a very strong spatial and temporal structure, and it comes with a lot of variation. What my ERC project was about was to try to understand what is going on. How can we actually explain some element of that variability? And it was done through a combination of fieldwork and lots of data crunching and some modeling, with a particular focus here in the Balkans and in the Adriatic, for which I will show you some data. So what did we do in terms of agent-based models? What we did is actually to go back to an existing model, which I find really, really, really nice, which is the dissemination of culture model by Robert Axelrod. Just going to try to explain very quickly what the model is. You have a grid, and you have a series of agents. Each of the agents have a series of features, 1, 2, 3, 4, 5, up to X. And each of those features is characterized by a trait, A, B, C, D, and so on, so on, so on, so on. So if in a way, if you take this agent, you have its fingerprint could be this, and the next one, its fingerprint could be that. In a very, very simple analogy, you can see that as their archaeology. So, I don't know, 3 will be the kind of pottery, 4 will be the kind of lithics, 5 will be the sort of agriculture they do. Which I find interesting because as an archaeologist, I'm interested not in the variation of one item, but in the core variation, the fact that archaeological material culture has an awful lot to offer in terms of variability, different type of data. So how does it work? It works through a process of homophily. So you have one agent, which is called the source, which will look at one of its, so this one is randomly selected. It will look at one of its random targets. They will discover that they share, in, for instance, in this case, 40% of the traits. And based on the amount of existing similarity between them, they will interact. And source will copy from target. So it's not a self-imposing system. You actually initiate the interaction and you receive. There's some literature showing that you can do it the other way around. It doesn't really change. So the reason I'm also liking this particular model, it's spatially explicit. So you start with your grid. You randomly select one agent, then randomly select one of its neighbors, and then it works. That's the simple model, 1997. I think last time I checked on Scholar Google, it has more than 1,000 quotes. It's one of those big guys in ABM literature. So it was kind of a challenge to say, oh, can we do something slightly different with this guy? So that's another thing that I need to say before I explain what we were trying to do is what the model does. So you make it run. And the way you visualize is generally showing that, for instance, this is the grid. And you can see that, for instance, in this area, all the agents are not indicated because they are all alike. Whilst here, for instance, these agents here are totally different for all the threads. And you keep on running. And then what you discover is that even though the more similar you are, the more you copy, you never get a totally homogeneous grid. You actually get convergence in some areas and disparity in other areas. And the way this will be structured is based on a series of parameters in terms of the number of features, the number of threads, the size of the grid, and so on and so on. That's the basics. It's a very simple, beautiful model that says, even if we decide to look alike because we look alike, nobody will ever look alike. And you can explain that in that very simple way. So the work that we did, well, to be fair, the work that Nellis Drost did in terms of, so Nellis is an ecological modeler, he had to learn a bit of archaeology. We had an awful lot of crazy discussion, and he did all the hard work in terms of coding. And then there was another part, which was, how the hell are we going to describe everything? And that's where the archaeology comes in. We did a lot of self-acknowledged toy models. We published that as Toy Story, which is kind of cool as well as a title. And I'll explain in a second why we decided to keep at the level of the toy. We explored an awful lot of things. I'm not going to go through every single iteration. That will take me a long time. What we did is here, especially go into the population, because the population question is a big issue in the spread of farming. Do you have a new population coming in, which is associated with those new domesticates? And what we did is a very parsimonious approach. One parameter, try to understand what's going on. Then add another parameter, try to understand what's going on. Try to add another parameter, try to understand what's going on. There's actually a fourth one, which we're still working on here. So how do we do it? We've made two changes. First, instead of having a total grid, you have to imagine that this is the edge of the world, and the world is here, and you have empty land. And the model keeps on going, normal way. But one every X step, if the randomly selected agent happens to be at the border, and if the randomly selected agent decides to interact with the void, at that stage it can clone itself. If it happens at a previous stage, nothing happens. So that's a way to say, okay, well, this is what's going to be the population engine. And you can set that parameter. And you keep on going. So what I'm going to show you is that's a normal accelerote, and that's our demic wave. And we've split it in 8, just to try to identify what's going on as this model will run. What is happening very fast is, whilst here everybody is distributed randomly and they start interacting, and you can start to see those regions where there's a little bit of homogeneity, as the front progress, you see these big, very homogeneous front, regions just behind the front. So as the population expands, it is very homogeneous. It's actually very logical given the parameters, because you clone, so you're identical, therefore you're more likely to interact with someone who's identical, and it generates this front. That's kind of interesting. What is much more interesting is at one point here they reach the end of the world, and they're very homogeneous, but behind, the interaction gap keeps on going. And what you see is that what was here fairly homogeneous starts to be broken down by the interaction with the diverse back of the front. And then eventually the model stabilizes. So what you have here is a two-step. You have a very low diversity as the front progress, followed by a high level of diversity once the front is not progressing anymore. The way we described that was to use a measure of diversity, the Shannon index, borrowed from information theory, which is also a tool that is sometimes used in archaeology, and I'll go back to it. So what you have here is this is the first quarter, and you have a lot of diversity, and it gradually goes down as the interaction process. These correspond to each of the blocks. By definition, they start at 0. There's nobody, there is no diversity. But you can see that this is when the moment these blocks get gradually inhabited, and you can see that the front becomes very, 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 very homogeneous. So as the front progress, it is very homogeneous. And then you have the interaction with the back that lead to this increase in diversity, and from there onwards, all of this part of the graph is accelerote as we know it. That was for demographic rates set at 1.5. We've actually, because we have no idea on how to control this and how to calibrate it, what we did was to explore a range of parameters. Basically, it works unless you make it go so fast that nothing happens anymore, or so slow that it's just not realistic. But it is actually very robust for a set of parameters. We've also added some drift. So instead of having people who perfectly copy each other, sometimes they get the interaction wrong. Even when you put drift, you get the same. When you put too much drift, you disrupt the entire model. But that is something that is a behavior which is extremely well known in Axelrod. The Axelrod model just doesn't like drift up to a certain level. So we just hit a limit of the model. But if you keep drift within the reasonable bounds which are known of the Axelrod model, the wave still works. If you put a local population, so you don't have simply people in one end and an empty landscape, you have people in one end and a few pockets of people who cannot grow. That is just the one constraint. It still works. If you put an awful lot of people, you still get that mini drop. And what is actually happening is that the front comes in very, very homogeneous and brings a huge sea of totally homogeneous thread that gets blurred by the local diversity, but you still get the same pattern. So in a way, we did not even try to calibrate because there was no way I think we could calibrate. Because we're hitting I could try to imagine a series of ways of calibrating, but I was not interested in trying to calibrate. What I was interested in was to imagine the behavioral properties of what would a spreading population do, what will it do to his culture, to the package it carries. So when it comes to the data, because at the end I'm an archaeologist, in a way, this is the sort of calibration stage, and this is the sort of validation. But we didn't see it as a calibration validation. We see it as a series of assumptions and a series of predictions. So if I just look very briefly at the assumption, homophilia is a potent evolutionary force. There's actually quite a lot of literature on why homophilia is important, and we know that it exists in the way people interact and as a force shaping the material culture. The low density local population, I'm not going to give you the example, but I could lecture on forever on why indeed the Mesolithic, the local population that's going to get all those elements is very low density. And why you have a high density population that comes in, well, I can show you one example, which is when you play with an awful lot of data, with a lot of C14 data. So what you do here is that you take all the C14 dates and you compare the local trajectories that you have in one region here, one region here, and one region here against the average. The red line corresponds to the introduction of spreader farming. So in Greece, so it comes from here, it gets in Greece early on, you can see that that's the signal you get in terms of number of C14 dates. The moment you get farming, you get a lot more. So that's clearly an indication that there is a new population coming in. We also know that now with ancient DNA that it's clearly a new population. It's just not a population boom. There are new people coming in. If you look then in the Danube area, you can see that the diffusion is a bit later. There is a gap in the process, but the moment the introduction here, you see that boom again. Likewise in the Adriatic. So at least from that point of view, and I could keep on going, lots of the assumptions of the model can be validated. I cannot put a measure, but I can validate it. When it becomes much more interesting is, what does the model predict? And how can I actually take a look at that with my not so good archaeological data? So what it predicts is a series of things. First, you will have a traveling front associated with an homogeneous cultural package, and that package has a lower diversity than the zone of origin. It's what you can call a Vander effect. The second thing is that that package will be made of threads that were randomly selected from the area of origin. The model does not consider selection. We can make it, but it has nothing to do with improved fitness. It's just randomly selecting what is happening in the zone of origin. The second important prediction is that you will have that two-step. You will have that low diversity followed by an increase in diversity. And the third thing is that that is an emergent property of the model, and it goes across the entire set of features in Axelrod. So if something like that is happening in archaeology, I should be able to track it in different parts of the archaeological record. Can I do that? If we look at the pottery, in the Adriatic, so just here, the early Neolithic is associated with something called the impressor ware, very homogeneous. What is really, really interesting is that from a typological point of view, that production comes from the Aegean, where it has a very, very, very low proportion. It is happening in pretty much every single assemblage at a very low proportion. And then all of a sudden, when it expands, it becomes the norm. That is exactly what we are expecting. You have something which is constituent of the diversity in the zone of origin that gets randomly selected and that becomes the norm. There is no selection process happening apart from random selection of one particular thread. What is also interesting, that's the impress ware. The moment you start hitting 5,005, 5,000, the impressor ware just collapses as a homogeneous group and is substituted by a series of local ceramic typological groups which are much more fragmented and much more reduced in terms of spatial distribution, which is an expectation of the model. Low diversity followed by high diversity. And I can do the same demonstration inland, where you have something called a Starchevo, which is followed by a multiplicity of local ceramic styles. So I have that trajectory of low diversity, high diversity. Can I do it elsewhere? Let's take a look. That's the work that was done by, in collaboration with Jane Gastrander at the University of Exeter. Let's do it on animal domesticates. So we've done it meta-analysis of the data for the situation in the Adriatic. This graph is actually going in a bizarre way, and we did not liaise before. This is the relationship between the size of the assemblage and the species richness. And actually here, there is a very, very, very limited correlation. That actually shows that it's not, some of the patterns I'm going to show you are not simply the product of difference in terms of size of the sampling. They are really patterns that actually do matter. That's the classical way of reporting this data. Phase 1, phase 2, phase 3, phase 4, each of them with a particular chronological bin. Because we wanted to try to test the model, we did that, but then we did something else which is slightly different. We did what we called the difference between first and second Neolithic. My first Neolithic is, regardless of the local earliest Neolithic across the Adriatic, because there's a big gradient in terms of earliest date, we take the first 500 years. So here, if you have an early Neolithic at 6,000, my first Neolithic will last from 6 to 5,500, whilst here, it will actually last from 6,600 to 5,000, from 5,006 to 5,001. We don't care about the absolute date. What we are trying to test is whether or not we have a behavior within a system that reproduces through time. So we've taken a relative date, the earliest 500 years, regardless of the introduction of the Neolithic, versus a second stage. And what we're trying to say is the first Neolithic less diverse than our second Neolithic? We used correspondence analysis, which is a technique now routinely used in meta-analysis, especially in zooarchaeology. And you can see that this is your first Neolithic, this is your second Neolithic, and you can see that this one, the dots which correspond to the site are within a larger space in terms of CA, of correspondence analysis, than this one. So this is a first indication that indeed there is more diversity in the second Neolithic. It can actually be a bit better than that. The way this correspondence analysis works is that it plots according to a series of axes which correspond to percentage of variance. And if you plot the species, you can see that, for instance, dimension 1 makes the distinction between, on the one hand, in this case, the wild versus the domesticates, whilst dimension 2 makes the gradient between different types of domesticates. If we take a look at dimension 1, so only this between our first and our second Neolithic, this is the violin plot you have here, there's actually no difference. But if you look at dimension 2 between this one and this one, this becomes significant. The reason why it is interesting is that it's a way to show that indeed there is a larger space of the correspondence analysis which is being used. And it's not a question of they hunt more or they hunt less. It is actually the differentiation happens here in terms of what kind of domesticated animals they use. And in the paper, we also rule out the fact that this gradient is not linked to environmental variables. There is no straightforward way to explain that in an environmental way. We think it's a process which is linked to that wave that we see in the model. If we do it for archaeobotany, that was one of the things done as part of the doctoral dissertation by Vander. I remember using correspondence analysis with Anne, and we destroyed our eyes on her correspondence analysis and just could not see anything. And then Nellis came with the model. And then we thought, oh, maybe we can try to something much more simple, which is a measure of diversity. And we used exactly the same technique, Shannon's H index. And what you see, there's a bit of a caveat. In the Adriatic, if you take this one versus this one, there's clearly a difference. And you do have a lower level of diversity here, and here there is much stretched. It actually does not really work in the other part of the distribution, which is in the Danube area. And that's interesting because it suggests that the model works fairly well in one area, but not necessarily in the other one, which is kind of cool. We have not demonstrated something that works every time because it has a series of parameters, and this process is very complex and very multiple in its making. So I am not expecting it to work every single time. And I can start to actually map where the behavior of what we see in the archaeology matches the behavior predicted by the model and where it does not. And that creates something which is very interesting. What was very nice also here, and that I think is the methodological challenge for archaeology, is having the model forces us to reconsider the data in another way. It was not simply a question of acquiring more data, it was actually a way of how do we actually crunch the data in a slightly different angle, which we may not necessarily have considered. And that was quite humbling. And I do say humbling because the last definition I want to use is humility, the quality of having a modest or low view of one's importance. I have no idea which of the German word would be the better, just blame Google. I find it a bit sad that it was very, very used and it's in decline. And I think that we can probably do a little bit better to get this going up. If we think in terms of ABM, we have to have this humility. We have to have this humility in the way we do it at the theoretical level. Holism is kind of always lurking at the background. One should take that into consideration. There will be other variables that you have not considered, but you still have to be neat, formal, explicit about the fact that you may not necessarily be able to answer it all, and that your explanation will lie within a space which comes at a price. This humility is also when we do it, and by I mean the when is when you put the people around the table. It's that notion of sacrifice. The fact that you have to take into consideration that you will not be able to force into the ABM some of the things because another of your contributors wants to put something else, and you have to try to through that dialogue. And that is a very nice and humble process. It is also a question of humility in how we do it, and that's the methodological work. It's the be ready to consider that you've been gazing at data and you've been acquiring data for quite a long time, and that you never really thought about looking at it from another angle, and that you have to pay attention to the way you're going to look at it, that you have to keep in mind that you have all those biases, which I spent pretty much 80% of my career and my work tried to work around. And that's where the ABM and the toy models can be very, very useful from that point of view. Thank you very much for your attention.